Welcome to the DIY Honda Garage channel. DT stands for Diagnostic Trouble Code, which is a code used by the vehicle's Engine Control Unit, ECU, to identify issues within the vehicle. In this case, DTC P2199 indicates a problem with the correlation between two intake air temperature IAT sensors. The IAT sensors play a crucial role in measuring the temperature of the air entering the engine, which is essential for the optimal performance of the engine management system. If the temperature difference between IAT sensor 1 and IAT sensor 2 is significant after starting the engine, the Powertrain Control Module, PCM, perceives this discrepancy as an anomaly and triggers this DTC. This code specifically pertains to the Honda Accord 2023 and newer models, making it important for owners of these vehicles to be aware of its implications on performance and efficiency. The next steps in the troubleshooting process will address how to correctly diagnose and resolve this issue. DTC P2199 pertains to the intake air temperature sensors, specifically Sensor 1 and Sensor 2, that are integral to the engine management system. The role of these sensors is to monitor the temperature of the air entering the engine, which directly influences the air-fuel mixture necessary for optimal combustion. Typically, IAT Sensor 1 is located in the mass airflow sensor assembly, while Sensor 2 is placed further along the intake path, capturing additional data about the air condition. By constantly evaluating the temperature differentials, the PCM uses this data to adjust fuel delivery and ignition timing, enhancing both performance and fuel efficiency. A significant variance in readings between the two sensors can signify a malfunction, prompting the PCM to store DTC P2199, which indicates that the system is potentially struggling to keep optimal air-fuel ratios and could lead to engine inefficiencies. When addressing DTC P2199, several possible causes can lead to this code being triggered. One notable cause is a faulty IAT Sensor 2, which may not accurately report temperature readings due to internal failure or damaged components. Additionally, loose or damaged connectors can disrupt the signal being sent to the PCM, affecting how the temperature data is interpreted. The engine coolant temperature, ECT, sensors are also critical as they can influence the readings of the IAT sensors. A failure in these sensors could lead to discrepancies and trigger DTC P2199. Proper investigation is essential to isolate these issues accurately, ensuring that any detected faults are rectified to restore the normal function of the vehicle's engine management system. Understanding the symptoms associated with DTC P2199 is vital for recognizing issues early. One of the most notable symptoms is poor engine performance. Drivers may notice reduced power delivery, sluggish acceleration, or irregular engine operation. Additionally, an increase in fuel consumption is often noticed, as the engine may adjust to incorrect air-fuel ratios. This inefficiency can lead to higher emissions and a failure to meet environmental standards. Finally, one of the most apparent indicators would be the illumination of the check engine light on the vehicle's dashboard, signaling the driver that a diagnostic issue has been detected. Recognizing these symptoms allows for timely intervention and repairs, preventing further damage and maintaining overall vehicle efficiency. The first step in troubleshooting DTC P2199 is to turn the vehicle to the off-lock mode and allow it to remain in this state for at least 6 hours. This waiting period is crucial as it allows the vehicle's systems to reset and ensures accurate readings when testing the IAT sensors. Following this waiting period, start the engine and let it idle for a minimum of 10 seconds. This process will help to observe if the discrepancy between the intake air temperature readings still exists, thereby gathering baseline data from both IAT Sensor 1 and IAT Sensor 2. By executing this initial step, technicians can evaluate whether the error persists and will play a significant role in determining the next steps in the troubleshooting process. The second troubleshooting step involves a thorough examination of the connectors associated with both IAT sensors and the engine coolant temperature sensors. Begin by checking the connectors for secure connections. Loose or corroded connections can lead to unstable signals being sent to the powertrain control module. Next, inspect the terminal pins for any signs of damage or corrosion. This is critical, as degraded terminals may result in poor conductivity, leading to inaccurate readings from the IAT sensors. If the inspection reveals that the connectors and terminals are in acceptable condition, it indicates that the sensors themselves are more likely to be at fault. Conversely, if any abnormalities are found during this inspection, addressing these connection issues can rectify the DTC. After completing repairs related to DTC P2199, a final verification step is essential to confirm that the issue has been resolved. Begin by using a diagnostic scanner to clear the DTC from the system's memory. This action resets the PCM and removes any stored fault codes, allowing technicians to monitor the vehicle's performance without previous biases. Following this, conduct a test drive to assess the engine's behavior, focusing on throttle response and overall power delivery. Monitoring the check engine light during this test is also crucial. If it remains off and no performance issues occur, it indicates that the repairs have been effective. However, should the DTC reappear or symptoms persist, additional diagnosis is warranted to ensure comprehensive resolution. To prevent the recurrence of DTC P2199, implementing a routine preventive maintenance plan is essential. Regularly checking the functionality of the intake air temperature sensors can help ensure they are operating within their designated parameters. Schedule periodic inspections of electrical connections associated with the sensors, focusing on the quality and integrity of the connectors and terminals. Cleaning any corrosion and ensuring secure connections can significantly reduce the risk of false readings and code triggers. Additionally, monitoring other related components, such as engine coolant temperature sensors, can ensure the overall health of the vehicle's engine management system. By maintaining these practices, vehicle owners can enhance reliability and reduce the likelihood of future diagnostic codes. In conclusion, understanding DTC P2199 is crucial for maintaining the health of the Honda Accord 2023 and newer models. This code highlights an important issue regarding the correlation between two intake air temperature sensors, which can significantly affect engine performance and fuel efficiency. Familiarizing oneself with the symptoms, possible causes, and systematic troubleshooting steps can lead to effective diagnostics and repairs. Ensuring secure connections, verifying sensor functionality, and maintaining routine checks can prevent recurrence and keep the engine management system operating smoothly. By following this comprehensive guide, vehicle owners and technicians can effectively address this DTC, ensuring optimal performance and longevity of the vehicle. Please like and subscribe to the channel. See you next time.